Hello there. So today we're going to talk a little bit about what is the molecular origin of some of the properties of things like silly putty or some of the jello or bouncy balls that we've made in some of our outreach videos. So if we kind of look at silly putty, and the same principle applies to any of the other materials that we made, like the jello slime or the borax slime bouncy balls or the silly putty that we made with cornstarch and glue. The same principle applies that these are, materials that are made up of polymers, so these are long chains, and depending on how quickly we ask the material to react, the properties change. So if you ask the material to react quickly, so for instance, if we bounce it off our hand, the ball of silly putty is only in contact with our hand for just a very short period of time, fraction of a second. On the other hand, if we take the material and try to squish it and apply a force for a sustained period of time, like several seconds, in that case, the material is able to be reshaped, and we sort of went from a sphere to sort of more of a disc-like structure. So what's happening at a molecular level? Okay, so we're going to kind of turn over to a little bit of an overview of what might be happening. Okay, so if we take our material, and here's sort of a surface, and we bounce it, right? So it comes in and bounces off that surface. Our materials, as we see, made up of long polymer chains that are linked together. That's sort of what we represent with these little Pac-Man-like structures, these little red, open things and the green things that fit in them. These are the bonds that link the polymers together. So overall, with silly putty, the same principle applies to, say, our borax bouncy ball. These are all one molecule. They're linked together, but the links are not permanent. So when we bounce the material, right, we bounce it off the surface, it's only in contact with the surface for a fraction of a second. So when I bounce it off my hand, it's only in contact with my hand for a fraction of a second. These green and red groups can't rearrange. On the other hand, if I apply some kind of force to the material over a period of time, so I squeeze it between my hands for a period of time, I give time for the material to rearrange. And so these green groups and red circles can rearrange and actually release some of this force or the stress that I apply to the material. So the material doesn't like that I applied a force to it, so it rearranges, and I give it time to do that. And that's kind of where a lot of the properties of things like silly putty, that you can stretch it when you stretch it slowly, but it bounces if you try to pull it quickly, or if you just pull it very quickly, it'll actually break. Because over that short time scale, okay, if we try to pull it very quickly, the bonds can't actually rearrange on that time scale. Instead, they'll actually snap or form into two pieces. So hopefully that was useful, and we'll see you soon for lots more polymer related content.